This is section 1.3a, linear equations. Now, a lot of what we do these next couple of days will be review, but as I said before, this review is important for the chapter and it's also important for calculus because the concepts that we cover in chapters 1 and 2 and also in 4, 5, and 6 are directly applicable to calculus, and it's very important for you to have a good background in these concepts and reinforce what you already know before you go on to calculus. Finding the slope of a line. You probably remember this from Algebra 1, and we've seen applications of slopes at other moments, especially in earlier chapters. We saw a little bit of it in chapter 10, for example. So anyway, finding the slope of a line is just y2 minus y1 over x2 minus x1 gives you your slope. Rise over run, if you want to think of it that way. A linear equation written in the form y equals mx plus b is in slope-intercept form. That form of the line is called slope-intercept form. The slope is m and the y-intercept is 0, b. The slope of a vertical line is undefined, and the slope of a horizontal line is 0. Okay, why is that true? Well, if slope is rise over run, a vertical line has infinite rise and 0 run, so it would be like having an infinite slope, and that's undefined. And the slope of a horizontal line is, if that's rise over run, well, it has infinite run and it has 0 rise and infinite run, so 0 over anything is 0. Example, graph the line y equals 2x minus 4. All right, I know that this is very easy for you. It's just really reviewing Algebra 1 and Algebra 2, but it's going to be important to know for the rest of this chapter and for calculus. So you can probably just do this on your own. Pause the video, do it on your own, and then resume when you have a line graphed. So let's go through the solution for this example. The equation y equals 2x minus 4 is in slope-intercept form. So m equals 2 and b is negative 4. We know our slope and our y-intercept. And then we can just plot those. We plot our y-intercept, 0, negative 4, and then I'm going to draw the slope because it's rise of 2 and run of 1. And once I have one little portion of the line, I can draw the rest of the line. Okay, so I'm sure you got that on your own. A linear equation written in the form y minus y1 equals mx minus x1 is in point slope form. Right, so it's still a line, it's just a different way of writing it. Kind of like how we did with parabolas, where there were different ways of writing parabolas even though they were all describing the same shape. Well, the same is true of lines. And so this is called point slope form. The graph of this equation is aligned with slope m passing through the point x1, y1. In this particular case, it passes through the point 4, 3, and the slope is negative 1/2. So this would be the graph of the equation y minus 3 equals negative 1/2 x minus 4. And that is the line with slope negative 1/2 passing through 4, 3. Now notice this, if we're looking at this just algebraically, and I'm going to just highlight, what I'm doing with this mouse arrow here. Y minus 3 equals negative 1/2 x minus 4. Okay, that doesn't look like y equals mx plus b form, but you can rearrange the terms until you get y equals mx plus b form. So as practice, if you wanted to do that, you could just go ahead and rearrange the terms to put it in a different format. Example, write the slope-intercept form for the equation of the line through point -2, 5 with slope of 3. Alright, so using the point-slope form, you should be able to express this as an equation, as a linear equation with point-slope form, and then you just transform that point-slope form into slope-intercept form. Okay, so pause the video, try to do it on your own, and then resume when you have an answer. Use the point-slope form y minus y1 equals mx minus x1 with m equals 3 and x1 y1 -2, 5. So we're just plugging in what we know. When we do that, we have y minus y1 equals 3 times x minus x1. And y minus 5 equals 3x minus -2. We just put in x1 and y1. Y minus 5 equals 3x plus 2. And now what we have to do, this is a complete point-slope form, but now what we have to do is rearrange terms algebraically until we get the slope-intercept form. And it just becomes y equals 3x plus 11. That's the slope-intercept form of this line. Write the slope-intercept form for the equation of the line through points 4, 3 and -2, 5. Alright, so this is something that you can also try to figure out on your own, and then resume when you have an answer. M equals 5 minus 3 over -2 minus 4 equals -2, 6 equals -1/3. All we did there is calculated the slope m. Because since we have 2 points and we know the line passes through those points, then the difference in rise and run from one point to another gives us the slope, and that's how we came up with -1/3. Now we can put it in point-slope form. So y minus 3 equals -1/3 x minus 4. Notice that it doesn't matter which point you use. See, now that we got y minus 3 equals -1/3 x minus 4, you can see that we used the point 4, 3, but we could just as easily have used the point -2, 5. It doesn't matter which points you choose. I suppose that it's easier in this case to use 3, 4 because there's no negative. There's no subtraction of negative as you would have if you put in -2, 5. But mathematically it would come out to be the same. So our line in slope-intercept form is y equals -1/3 x plus 13/3. Here's a summary of equations of lines. These are all the different ways to write lines. The general form is ax plus by plus c equals 0. A vertical line is just x equals a, because all you have is an x coordinate and there's an infinity of y coordinates. A horizontal line is y equals b, because all you have is a y coordinate and there's an infinity of x coordinates. Slope-intercept form you know already, y equals mx plus b. Point-slope form we just talked about. And two-point form, you don't really need to remember two-point form because you can just derive it easily. All two-point form is, if you look closely at this, all two-point form is instead of writing m there in the point-slope form, they wrote the way to calculate m, which is y2 minus y1 over x2 minus x1. But I don't think it's worth memorizing the two-point form. All you really need to know are the general form, the slope-intercept form, and the point-slope form. The classwork, page 34, write those numbers down, and we'll see you in class.